Hello, everyone. My name is Gaurav Seth, and today I'm going to talk about using AI with App Service to deploy differentiated web apps. I'll be joined by Yutang Lin and Tulika Chaudharie. Now, before we start the session, a quick peek into the agenda for this session. So I am going to talk about AI-enhanced migration and modernization, how to integrate generative AI capabilities into an existing ASP.NET Framework web application. Yutang is going to talk about Azure Load Testing plus automatic scaling and intelligent observability, whereas Tulika is going to talk about observability with partner solutions and how to integrate generative AI capabilities with .NET. Now let's start talking about AI-enhanced migration and modernization. Now, before I get into the demo and code, here is a quick topology of the demo web application. Now, all the resources for the demo web application are deployed to a landing zone. Now, for context, landing zone is basically an environment which focuses on key design principles around security, network isolation, app modernization, innovation, and sort of things. So what we have in this web app is a framework web application called DevShop, which is backed by an Azure SQL database. And remember, all the communication between different endpoints, be it OpenAI or database, are secured over managed identity. And obviously, they are all isolated within their own virtual networks. So now here is the code of the existing framework web application. Now, as a first step, what you need to do is you need to download an extension from Visual Studio Marketplace called as Azure Migrate Code Assessment Toolkit. Once you do that, once you download the extension, install the extension, you'll start seeing a new option called as Re-Platform to Azure. Once you click that, you'll have two options, either to create a new report or open an existing report if you have already used it in the past. I'll click on New Report. And as a first step, you actually need to choose what's the target for your web application on Azure. Now, this being a framework web application, for me, the target is App Service Windows. I click Next. Now, if you have more than one project in your solution, you can either analyze both of these projects, or you can simply focus on analyzing a single project. I'll just analyze the single project. Click on Next. Now, in addition to the source code and analysis of different configuration settings, you can also decide to include binary dependencies. Once you make your selection, you click Analyze. Now, within a matter of seconds, you will be given a dashboard which will basically give you a summary of all the different issues that are being reported. Now, let's go and look at some of these issues. As you can see, because my web application is connected to a database, it's reported that we are using system.data.sql client. Now, although this will work in Azure, but the guidance here is that maybe you should upgrade. Before you migrate your web application over to Azure App Service, it's good that if you can migrate your data dependency over to Microsoft.data.sql client, because again, if you want to connect using managed identity credentials, or that's basically the NuGet package where we will have a lot of innovations that will land in the future. Now, if I want to understand how exactly to do that, I can simply click on Ask Copilot. So if you have the GitHub Copilot extension installed, you will have this option to go ahead and query GitHub Copilot for suggestion in terms of what are the next steps that I need to focus on. And as you can see here, what this tells me is to go ahead and resolve this issue. What I need to install this package called as Microsoft.data.sql client. And once I do that, I can replace all the code which looks like this with basically Microsoft.data.sql client.sql connection. So that's how easy it becomes if you start using the GitHub Copilot extension within Visual Studio in terms of how do you go ahead and modernize and optimize your code before you start migration to Azure App Service. Now what I've done is, in the interest of time, I've already gone ahead and migrated this web application. Now again, for migration, we have so many tools already available. You can either do a simple right-click publish from Visual Studio, or you can use PowerShell scripts, or you can use the integrated bulk migration experience within Azure Migrate. As I said a bit earlier, all the resources for my web application are deployed to a landing zone, as you can see here. And now this is the web application which I already migrated. Now, before I get into the actual web application, I just wanted to point out that as a standard security guidance, you should be moving your secrets or your connection strings over to Key Vault, and that's exactly what I've done here. Now, this is my existing web application, which I migrated. This is a dev shop web application. You can go ahead and buy products. And this is the generative AI capability that I was talking about. So what I've done over here is, this is my existing web application. I migrated it to Azure App Service. And then I have this new option called a Chat with AI Assistant. Now what happens is, I can go ahead and ask a question. Because I'm in travel, I would want to ask a question related to travel accessories. Once I click Submit, what happens behind the scene is, now this query is actually going to be sent over to my Azure OpenAI endpoint, and here is the response that you get. Now, I just want to give a quick call out that the response that you see here is coming straight back from Azure OpenAI endpoint. I have not grounded the response against the product database that I have used, because that's a demo that my colleague Tulika is going to showcase in a little while from now. Let me close this, and let's go and look at the code. So that's basically my chatbot.aspx page, where I just created that screen, the entry screen, where you could post your question and query. What I have here is a jQuery, which calls into my chat controller. Now, from a chat controller point of view, there are three important things I want to point out. First, I am using the Azure OpenAI Client SDK for .NET, as you can see here. So you need to actually go ahead and call this NuGet package, which is azure.ai.openai, and also the azure.identity package. Once you have done that, the other important piece of code that I want to highlight here is the whole managed identity credential section. Because remember, everything is securely communicating using managed identity credentials. So what I'm doing here is, I am creating the managed identity credentials and then passing them and creating the connection with Azure OpenAI. Once I'm connected with the Azure OpenAI, what I do next is I go ahead and use the chat completions API. And as part of the chat completions API, I am using the Turbo 3.5 model, and I pass a system message, which is actually a prompt. So my prompt looks something like this. You are an employee of a store that provides product recommendations, and I want the result to be limited to a single recommendation. Along with this system message, what I do next is I go ahead and pass the actual user query over here. Once I send the user query over to chat, to basically the Azure OpenAI endpoint, I get the response back, and that's what I display on the screen. So as you can see, I mean, with just few lines of code, I was able to add generative AI capabilities to an existing framework web application without needing to write a .NET, say 7 or 8 web application in this case. Now with that, I'm going to switch back to the PowerPoint. And now my colleague Yutang is going to talk about load testing plus scaling.
Thank you, Gaurav.
Thank you, Yutang.
All right, hello everyone. Welcome to the load testing, scaling, and intelligent observability part of our demo today. I just want to give you a quick overview on what this demo is going to look like. First, I will start with a web app that I have automatic scaling enabled, and then I'll use our Azure Load Testing integration to help you understand how automatic scaling works. At the same time, I'll also do another comparison with a run from our rule-based scaling. And the last scenario in this is I will have another test run that I purposely generated a lot of load that I know cannot be handled by my web app, so I could lead you to our intelligent observability tooling to help you understand how you can get started with diagnosing your web app for scenarios, let's say, such as web app slow or high exception rates. So from here, let's actually begin our demo today. All right, so let me find the right window. OK, so here you can see I have started first with my application. This is where we have our automatic scaling enabled for the web app. Automatic scaling, you could just as easily think of it as automatic cruise control. So what this does is it lets you, as the user, pick the number of instances you want, or max instances you want to be able to initiate for your web app. And from our point of view, what we'll do is looking into the incoming HTTP requests and also the underlying CPU usage, we'll use this data to understand how we can dynamically allocate resources for your web application. And if, let's say, we notice that there is a less number of instances needed, we'll start scaling things back down as well. But once, let's say, you have this set up, you want to understand, OK, how do I get started and understanding, does it work? Do I have the right configurations? This is where I'll move on to the next part of my demo, which would be the Azure Load Testing. Let's go ahead and click on Load Testing under Performance Blade. So Azure Load Testing in general is a standalone resource on Azure that allows you to test different endpoints or resources. In this specific example, or this integrated view that I'm showing you right now, this lets you see all the test runs that have been done that are associated to the given web app where it's opened from. So the first scenario, let's go through a test run that I have done against my automatic scaling. By default, Azure Load Test, what it'll do is it'll give you a run-through or high-level data of the different information that happened to your load test. So example, you can see the statistics right here. If we scroll further down, we have client-side metrics. However, I'm more interested in showing you a more exciting part, which is going to be all the way down as we scroll, will be the server-side metrics. First, there is CPU percentage, as you can see right here. Then we have requests. And if we go all the way to the bottom, we have HTTP response time as well as another metric. However, one of the main metrics that I want to show you today would be the one that you see at the bottom right. So this is your instance count metric. The instance count metric is a new metric that we have released with automatic scaling GA that helps you understand how many instances have been initiated for your web app when automatic scaling has been configured. So if we look at this example, I'll just scroll a little up so you can see a bit of comparison. Here, as a request started going for your web app, you could see that automatic scaling started ramping up and initiating up until 10 instances. That was the max that I set it to. And then as the load continued on, it noticed that, OK, I could handle the same load, yet still provide a very low HTTP response time and also ensure that the CPU usage is pretty low as well. So as you can see, it started deallocating a few resources, and we're averaging at about 6, 7 throughout the rest of the load test. So this is how you could use Azure Load Testing to help you figure out the right configurations for your automatic scaling. The next scenario I want to show you is do a comparison. In this comparison, I want to compare a rule-based scaling that I have done and also with that same automatic scaling that I have just shown you. By the way, this compare feature is something that is very useful that you could use to compare scenarios such as code changes or configuration changes as well. But for this scenario, there are two things I want to call out. One is first, we have automatic scaling right at the top. And then we have rule-based scaling right at the bottom. So team blue is automatic scaling. Team pink is rule-based scaling. So the main thing you want to remember by the end of this scenario is that we want to see team blue succeed. So first, let's just go all the way down to the part of our different metrics, such as the request. So first here, when we look at the request, we could see that the request for Team Blue, which is automatic scaling, is doing really well. It could handle almost double the load of our rule-based scaling. What this shows is that, just so you know, Azure Load Testing, because it sees that my web app is able to handle things with still very low HTTP response time, it will let the virtual user still generate more different requests throughout the load test. This is why you'd see it's a lot higher in comparison to the rule-based scaling, which is pink. So at the bottom here, I want to show you the response time differences between Team Blue. Team Blue is still doing really well. That's why you could see there have been a lot of additional requests that has been done through the Azure Load Testing. And last, I want to go through another metric, which is the CPU percentage. In the CPU percentage, you could see that also the automatic scaling, Team Blue, is doing so much better than it is with Team Pink. So hopefully this lets you understand the different differences between the two configurations for rule-based scaling and also automatic scaling. The last scenario I want to go through with you is to help you see just a web app that I purposely generated way too much load for. So here, you could look at this web app. I purposely actually scaled things back down just so there could be a lot of load generated. It has high error percentage, and at the same time, if you look at the CPU percentage, it is really high. And actually, let me go to the other one, which has a lot more high CPU percentage. OK, so if we scroll down, here, you could see CPU percentage extremely high throughout the run. If we go to response time, it's also about like 5 seconds. No one wants their response times to be 5 seconds for the web app, right? So here, I know that my web app has been extremely slow. So what could I do to help me get started with diagnosing this situation? First of all, we have the handy-dandy Copilot button right at the top. If you click on this Copilot in Azure button, you could ask it some questions to help you get started. So what I would do is I would say web app slow, last 5 hours. I say 5 hours because I know I just ran this load test not too long ago. So what the Copilot would do, oh, sorry. OK, so what the Copilot here would do is that it'll look at the data. It knows the context of your web app is this particular web app. It'll look at data such as metrics that are associated with web apps being slow. So what it will do is it does take up to a minute for it to generate to generate data. So I don't want us to watch it load. I'll just show you what I have already preemptively asked a couple minutes ago. Here you could see that I said web app slow last 5 hours, which is the exact same prompt that I've given it. So what it says is here, I have potential root cause that Copilot and Azure provided me. One of them being high load average detected, which was what I expected already. If we go down, it says, here are some potential solutions that we could do. I'm not going to go too deeply into this for this part of the demo. What I wanted to show you is this button. What this button does is that it could lead you to another tooling, which is our web app slow detector through Diagnose and Solve. So the Diagnose and Solve tooling, it'll help you look at the different data points for when the web app has been slow. And what you could easily do is you could do a click and a drag throughout this time frame. And you can look into things more in-depthly through a zoom-in view. So if you scroll all the way down, you could also see different observation and solutions that it wants to provide you. Now, the last part of our demo that I want to go through with you is the smart detection integration with Application Insights. So for this particular example, you want to make sure you have Application Insights enabled for your web app like I have. So Smart Detection and Application Insights has two different parts. One at the bottom, which is the original Smart Detection, and the one at the top, which is the Alert integration. This feature is still in preview, but I do want to show you this because it's very interesting. So first, let me just go ahead and go look at the different detections that it has provided me in the last 30 days, just so you could see the different examples it has caught. As an example, here we could see that we have latency responses, potential memory leaks, exception anomalies. So let's go dive a little bit deeper to one of them. In the exception anomalies, you could see Smart Detection has, let me just do it a little bit smaller so you could see a bigger view of it. So during this time, it has noticed that I have an increase in exception counts throughout this period from, let's say, the 4th to the 6th. This was a time when I generated another load test that has caused a high load into my web app that I purposely know my web app cannot handle. So just so you know, Smart Detection uses machine learning behind the scenes so that it can understand what is the expected error rate for your web app, so that in the scenario when there are some error rates that goes way above the baseline or the threshold, it will start generating alerts such as this for you. All I had to do was just enable alerts for Smart Detection, and everything else was hands-off from my side. So let's just go all the way down, because as a user, I am interested to know how can I get started understanding what this exception rate is. You could go into additional details here at the bottom. And what you could do is look at the view detected exceptions. So with this scenario, what it will show you is that it will open up a log analytics view within Application Insights where you could see the different logs that are associated with your exception during the time that Smart Detection has noticed something. So in this scenario, just real quick, I want to go through a KQL mode, which is our CUSA query language. So in this mode, you could see Smart Detection has already pre-generated queries that helps you get started with troubleshooting. And then let's just minimize this just so you can look at the logs. Here we could see system timeout exceptions that it has found. If we scroll all the way to the right, we could see different system timeouts, mostly to do with here. You can look at the ones here such as SQL client, a lot of SQL client exceptions and exceptions network-related issues that I'm seeing in the logs. What this tells me is perhaps when I did my load test, there is a bottleneck within my database that maybe I forgot to scale it. And hopefully this could help you start getting started with understanding how you could minimize situations and errors such as exception rates or web app slow. With this, I'll actually switch to the deck again. So in this part, I want to now welcome Tulika, who will talk about observability with partner solutions.
Thank you, Yutang. So recently, we announced public preview for the sidecar pattern. The sidecar pattern is an architectural pattern which allows you to take different components of your web application and run it as separate containers. These containers can then be added as sidecars to your main application and run together. For the last few months, we have been working with Azure native ISV service partners to bring some observability integrations for you. The three partners that we've been working with are Dynatrace, Datadog, and New Relic. Today, we are going to show you how you can take the images provided by these partners, load them as sidecars to your main application, and then see your metrics, logs, and traces go into the respective backends. Switching over to my demo machine, so here I have the same DevShop application. I can run it and see it is the exact same application that Gaurav had, with one key difference. I have containerized my .NET application. So you can see that there is a main container which is running. Now, Sidecars is available both for container apps as well as code-based apps. And a little bit later, I'll show you the integration with code-based apps as well. The important thing over here is I have Dynatrace running as a sidecar. Now, this is based off the image that Dynatrace gave us. And all I've done is taken the image and pushed it into my own container registry so that I can take advantage of things like managed identities for secure Docker pull. So we've got the image going. We also set up some environment variables. These would be, again, Dynatrace specific, like a tenant token, just to make sure that you're connecting to the right backend. Now, to show you the integration, I've run an Azure load test on my app. And now if I go to Dynatrace, the first thing you will see is that it has recognized that this is a .NET app. It has also recognized that this is the DevShop.NET app that we've been using. And though you can look at all the metrics, the one I am often interested in when I'm doing a load test is what is the CPU usage for the host. And you can see that when I ran the load test for the 5 minutes, the CPU usage went very high, which means that maybe I should take advantage of the automatic scaling that Yutang showed for my application. Now, doing such integrations also allows you to take advantage of some of the innovations which are being done by our partners. Dynatrace has been working on Davis Copilot, which allows you to use natural language to query your observability data. So here, for example, I'm using natural language query, which just says, summarize all logs by log level. And immediately, I can see that in the last few hours, my application generated more than 2,000 errors, which gives me an immediate indication that this is something that I should investigate further. Moving on to the next integration, this is with Datadog. And again, it's exactly the same thing. I have the main container running a .NET app, and I have Datadog running as a sidecar. Again, this is based off the image that Datadog has provided us. I've just added it as a sidecar to my app. Now, I could look at the same logs and metrics. With Datadog, I want to show that how we are taking the application log, which my app is generating, and it's being multiplexed right into Datadog. The advantage of this is that now I can use things like the group queries. So you can see that I can group by fields, patterns, and even configure watchdog alerts, which will notify me if there is any abnormal things in my logs. Moving on to my final integration, this is with New Relic. And here, just for a change of pace, I have a Python application, and New Relic is added as a sidecar. So you can see the New Relic sidecar. There is one major difference in this sidecar container, and that is this sidecar is using OTel or OpenTelemetry. OpenTelemetry is an open source observability framework which is vendor and tool agnostic. So what it really means is I've connected this to OpenTelemetry to New Relic, and we can see the logs flowing just exactly in the same way. Going and looking at my Python app real quick, there's nothing much happening. I'm just generating a random number between 1 to 6 to simulate the throw of a dice. And then the most important thing is my Docker file. And here, the first thing to note is it is being built off the OTel image. So it is New Relic based on OTel. And we also have the OTel config, which actually tells us that we are going to send the data to New Relic. If I go to the OTel config, this is where I'm specifying the New Relic API key, just to make sure that OTel knows New Relic is our backend. I'm also specifying the pipelines which I'm sending, which is traces, logs, and metrics. If I go to New Relic, again, I ran the similar kind of a load test. And the thing that I can notice over here right away is when I ran the load test, my response time went very high. And this is, again, gives me an indication of something that I might want to see in my app. If you want to know more about Davis Copilot for Dynatrace, we have Jay here from Dynatrace. He would be happy to answer any questions. We also have partner booths of Datadog and New Relic at the hub in case you have any questions with that. And we are working with Elastic Observability. So in the next few months, you should get some more updates on how we are integrating with Elastic. With that, I am moving over to the PowerPoint once again. And my next demo is about web jobs. Web job allows you to run a program or a script on the same instance as your web application. So we often use web jobs to run background tasks for your application. These could be things like doing some kind of image processing, writing things to the database, cleaning up the logs, and so on. Here, I've created a web job for my dev shop, which listens for files to be added to an Azure file share. As soon as it figures out that there is a file, it will read the file, the JSON content of the file, and add it to my product catalog in my SQL database. Let's switch into our demo and go to my next set of browser tabs. So here, I have the same dev shop application we've been working on. As you can see, I am looking at accessories. I have 3 accessories right now. The web job I'm going to show is going to add another product. So firstly, for the web app itself, you will notice that I have added a storage mount. Azure App Service allows you to bring your own storage. So this is in addition of the storage that we provide by default. So here, I have the additional storage. And you can use this additional storage to do things like write log files, write images, and so on. The other thing that I have is the web job. That's the program that I'm going to run. You can add a new web job by clicking on the Add button over here. You specify the name of the web job you're going to add and the file, which contains your code. Now, I'm using a .NET web job, which means the file I uploaded was a zip file. But if you're a Java developer, you can upload a jar file, a war file, or even just a shell script and have it run as a cron job. You can specify whether your web job will be continuous or triggered, and you're all set. So now let's see this in action. This is Storage Explorer because I'm going to upload some content. I already have a content. It's basically a JSON file with some product information that I'm going to drop in. So I'll click on the Upload button. And I'll take the 2 files I want. I also have an image to go for my product, hit the Upload button. Now, my web job is listening for files to be uploaded over here. Once it figures out a file, it will read the file, add it to the database, and delete the file from here. It runs every 3 seconds. So hopefully, it should get picked up really fast. And see, it's gone already. And just to show that it's working, I can go and refresh this page. And you can see that the crossbody bag has been added in my product database. Let's look at the code real quick. As I mentioned, this is just a console app, which means you can basically write any code. Here, the code that we are doing is I'm creating a directory info object. Remember, we mapped products as a storage account, and that is now available as a directory for your web app. And once we read a file, we are doing some JSON deserialization. That's what is happening over here, the JSON deserialization. We do that and then add it or update our database. So that's about using web jobs with Linux App Service. Now let's move on back to our slides. And we've already seen this one. So now we are going to our most exciting demo, I think, which is adding generative AI capability into your web application. Before we go into the demo, let's take a look at the application architecture. Again, exactly the same thing. We have the DevShop application. And just like Gaurav did, I'm going to add a chat assistant to that. For chat assistants, I'm using the chat completion API. However, there's one major difference. The difference is that I want to cache the responses into a vector cache, which is running as a sidecar to my main application. This allows your web app to be more performant and have less latencies. Now, to add a response to my vector cache, I need to vectorize it, and that is being done by the embedding API. Finally, I don't want Azure OpenAI to give me generic product information. I want it to give me information about products which are in my database. So for that, I have implemented Azure AI Search. And there is an index of all the SQL products that I have with Azure AI Search. So every time you ask it about a product, Azure AI Search is going to look in the index, find the product that you're asking a question about, get the product name and description, and then pass it as a context to your OpenAI. So your chat completion API, in essence, is simply working as a summarization API. So now let's move on to the demo. So here I have my DevShop application. I can browse the application. Let's see how the chat works first before we look at the demo. And I'm going to just browse to a particular product because I'm very bad at typing, so I have it all in a notepad. And this is my chat assistant. I can ask it a question. And I've got the question right here. and I hit submit on it. Now, once we hit submit, one of two things can happen. It can either find the response in my vector cache and just fetch it right from the vector cache, or it could make OpenAI, it could first do the search and then make an OpenAI call. Here, it came back pretty fast, so I'm thinking that it came from the cache. We can continue asking more questions. How many pockets does the Blazor have? And this should be now pretty quick because we've built up a context of the product that we are interested in. And we can go on and on asking questions. The two things I want to point out over here. One is we are maintaining the context of the product on which we are asking the question. The second thing is we are also maintaining the chat history. And I'll show you how we are doing that in the code. Let's switch to the code. Now, as you can imagine, for this kind of an application, we have to set up several things. The first most important thing that we are set up is our search client. And this is where we are creating the search client. We are passing it an index. Remember, I spoke about the index, which has all the SQL data. That's the index that we are passing over here. So moving on. Now, every time the user sends in a message, we query the message from the search client. So that's what we are doing over here. We're taking the message and querying the search client. And we are retrieving things like the product description, the product name, the product ID, which we are going to pass to the chat completion API. We have also the vector cache that we spoke about. For vector cache, we are using Quadrant, which is an open source vector database. And the interesting thing that you might note over here is for the vector cache, I'm connecting to it on localhost. And you might wonder, how exactly am I talking to localhost from a web app? That's because my vector cache is running as a sidecar to my main application. Therefore, they can share the same network namespace and be able to talk to each other. Just showing this really quick. So here is our web application. You can see that this is a code-based application. So it is code-based. It's running .NET Core. We still don't have a portal integration for adding sidecars for code-based applications. We are working on it, and it should be available in the next few months. But you can absolutely right now use an ARM template and add sidecars to your code-based application. And that's exactly what I've done over here. Just showing you the ARM view of it. Over here, we can see that my site has a site containers collection. The site containers collection is where we have our containers. And the site containers collection has an image, which is the Quadrant image that we are using. We are using it right off Docker Hub. So all this is set up. We have a vector cache set up. We are using the semantic kernel over here. Semantic kernel is an open source SDK which allows you to connect to different LLMs. Here we are using it to connect to our chat completions, you can see over here, as well as the text embeddings. Finally, everything is set up. Remember, we were maintaining the chat history, and that's the portion over here, the chat history. We have taken a very simple approach over here in maintaining chat history. We are doing that using the HTTP context and session state. If you have an app which is running on multiple instances, you might want to use Redis cache to make sure it scales across all instances. So our history is done. We have to create the prompt template. Again, Gaurav showed you how to create a prompt template. The only difference is I'm using semantic kernel, so therefore I'm using a semantic kernel function over here, as well as passing in the template that I'm using. Now, the only thing left is once I do the search, find the product based on the user message, I have to stream it back to the user or the web page, and that's what is happening over here. We have this function which called invoke streaming async, which is streaming it back. We are chunking the message while we are streaming it. And after we have streamed it back to the web page, we also need to make sure it is added to the session state as well as the vector database. So here we are adding it to the session state, and here we are adding it to our vector database. So the next time you query, we can just take it from the cache. So this is how you can add generative AI capability to your web application. Moving on back to our slides. So in this also brings us to the end of our session. In summary, we talked about how you can modernize your .NET Framework app and migrate it to Azure App Service. We looked at load testing integration as well as taking advantage of automatic scaling. We saw some good examples of intelligent observability. And finally, we looked at integrating generative AI into your web application. I obviously don't know how to use the clicker. We are also working on the OpenAI library for .NET. This is a library which gives you parity with OpenAI Python and JavaScript and TypeScript. If you want to learn more about it, there is a helpful link over there. But you can use this library if you want to take advantage of GPT-4o or the Assistant v2. If you want to get started on App Service, here are some helpful links for you to get started on it. We have a whole playlist of community stand-ups that we run every month. So if you want to see what we've done over the last few months, you can take a look at the playlist. We regularly post updates on X. So please do follow us if you want to know what's happening with App Service. And finally, just after this session, we have another session on Azure testing services. And my colleagues tell me it's going to be very interesting. So if you have time, please do attend that session. Me and my colleagues are going to hang around here for the next few minutes. If you have any questions, any feedback or comment, we'll be happy to talk to you. We are also there in the hub on the 5th floor and the app service booth. So if you don't catch us over here, please do chat with us over there. And we are always happy to talk to you. Thank you very much for your time.